let's get into our project. Today we're going to do our first plugin, okay? And I'm going to walk you through the steps of the plugin. The plugin is called Open Sound Control. Has anyone used Open Sound Control? It's otherwise known as OSC. Has anyone heard of MIDI before? All right, so MIDI is used for music, right? MIDI is 1980, 1981. It was invented, and you have to use these really big cables, right? And somebody said, "Oh, the future of music isn't MIDI because all that cabling. It's going to be the internet. It's going to be Ethernet or Wi-Fi. So let's replace MIDI and do Open Sound Control." Open Sound Control is just MIDI over internet, kind of. Okay, it's a URL. It's usually done on channels, right? My website plus this object, my website plus that object, and we keep it separated by URLs, which I'll show you in a second. So the whole world went towards Open Sound Control, and now the only digital audio workstation that uses it is Reaper, I think. Like, it's not used in MIDI at all. It's used for triggering the videos in Times Square. It's used for video mainly. It's used for interactive installations. It's basically it's kind of like the Hogwarts of our department. It's like what gets things magically happening, and I think hopefully work locally. It also is the reason why I couldn't do what I was going to do last week with the iPad is because it's blocked in the NYU network. So we have a sandbox network that we can use where it's protected and we can do it. Hopefully I won't need it because I'm only going to do it locally on my computer. But it's something to keep in mind as we start trying to, like, normally this demo I start connecting all my computers to your computers, but that might be a little bit too much for today. So Open Sound Control was pretty much developed for Macs. And so it is a part of Max. Max is a company called Cycling 74. I just added this link to the syllabus. We're only using it for the first half of the semester, so feel free to try your 30-day trial if you want to now. It does have a student monthly fee or yearly fee for it. I think that you get it for free, though, by being IDM student. We have a network license. Just talk to Elton because Luke is an employee at Cycling 74. So we have like network licenses so that if you're on the floor, it'll log you in, and when you leave the floor, it'll log you out, kind of thing. So feel free to download this and install it. It's fun. It's a very visual way of learning all these different data types and interactivity and really driving our scalar parameters and stuff inside the engine. So we need to talk to these two pieces of software, and we're going to use a plugin called Open Sound Control, which I have provided for you. Let's see what's the best. OSC UE4. If you search for OSC for UE4, don't even worry about this. I just let you know that this is something I pulled off of GitHub and I compiled it for you, so you don't have to worry about doing it yourself. I have placed it in the project. In the Slack for you under Documents and Demos. You'll notice that there's two versions. Mac people use the Mac one, and Windows people use the Windows one. Okay. And I'll be showing you the Windows one. I'm sure I can show you the Mac one anytime you want to. So I've opened up our project, and it's great to see it, but we're going to let it go away because we're going to make a plugins folder real quick for it and install this plugin. Here is our project folder. And to make a plugins folder, both Mac and Windows, next to all these other folders at the root of our project, I'm going to make a new folder called plugins. That's it. And then I'm taking the Windows version. You guys will take the Mac version. That have Macs, and you guys have the Windows version. We'll take the Windows version. Going to download. Or actually, I don't need to because it's already on my computer 100 times. But what the hey. There it was all along. Alright, so inside this folder is a little folder called OSC. Here's my plugins folder, dragging it in, installed, done. I'm now going to open up my project again. It's an internet protocol, meaning that it has to connect to computers, and oftentimes when you're doing internet, you have to deal with different. We deal with URLs, right? But also your computer has an IP address, and on that IP address, there's a bunch of different ports. There are thousands and thousands and thousands of ports. Every time Adobe opens up, it sends phones home on these ports to the internet to try to get you if you're hacking it. And there's a lot of different. That's like one case. There's thousands of ports. Basically, 6,000 through 9,000 are reserved for creative coding. All right. When Max turns on, it's by a company called Cycling 74. It sends a ping on 7474 on the internet to tell Cycling it opened up. All right. So we're going to connect these two things over our local host. Let me start showing you OSC. So here's Max. And Max is kind of the reason I went back to school, because I opened it up a piece of software and it had nothing there. And I was like, oh, how am I going to learn this? So I'm going to have to find somebody who can show me how to use it. And so actually my thesis was done all in Max before I knew about the Unreal Engine. All right, so if you do new, patcher, or control new, here's our blank canvas. In this version of Max, they have a bunch of things to help you, which can make it easier. I don't know if you need to have a calendar in here. I know that's a little too much for. But in general, the different objects are at the top, and as you hover over them, they have different keyboard shortcuts for what number. How do you bring them out? And we could bring out, first of all, let's say let's bring out a number. Drag it, and I have a number box. Right? This is just like Unreal in that it's data flow node-based stuff, but instead of Unreal, which goes kind of left to right, this goes top to bottom. It really feels like a waterfall coming down. Right? So this is a integer box, and if I lock the patcher here at the bottom left, I can scroll on it, and I can see here we have some numbers. Okay? If I keep it unlocked, the secret here is if you hold down Control, you can do the same thing. It saves a little bit of time to not to keep unlocking and unlocking to do this. All right? So boxes can connect to boxes, right? Here's another integer box or number box, and if I connect them to the two, one drives the other. Data flow. Okay? But if I want to, let's say I have this huge, spaghetti web thing or whatever, I want to make it a little portal, right, between two different things. I can use a new object to send and receive. Here is the object box, also the end. And in it, I'm going to type names of things. And I want to make a send and a receive. But because I can have many sends and receives, I want to give it a new name, right? So I want to give it a unique name that only connects these two boxes in the world. So this one's called Bob. Yeah. So to send from Bob, I'd probably have to also receive on Bob. Makes sense, right? So let's now receive on Bob. I'll not know how to spell receive, and then I'll say Bob. Nothing's up my sleeves. These two are not connected, but they're connected in the world. Send and receive. If I want to do this over the internet, I would have to start using this OSC. OSC is a way of packaging, Open Sound Control is a way of packaging the UDP protocol, which is like we call it a user datagram protocol, UDP, which means numbers over the internet. So speed up a little bit. I'm going to say instead of this, I'm going to send it to, I'm going to say UDP send instead. Actually, let me leave these other objects so you have them for reference. So these two, they know what they're doing. But now if I have another number box, which is I, and I can do a new object by hitting N, UDP send. I need that IP address, right? Because I'm doing my own computer, well, that's called a local host. So I can just write out local host. And then instead of saying Bob, I'm going to distinguish, I'm going to put like a new port. Right? I'm going to say a port that we can use, and I'm going to use the port. Doesn't matter. It's whatever I make it, it'll work. So I'll just say like 8888. I'll do, because the creative code is between 6 and USP. Gotta spell things right. UDP. There you go. Localhost. And you notice that these things auto fill, right? UDP send. I could have just selected that, done localhost, and then the port. So if I'm sending it, what do I also have to do? I've got to receive it. So say new object UDP receive. And how do I know which one it's connected to? It's the port. So I just want to receive on 888. And then I have another box. And now you have to take my word for it that it's over UDP instead of the send and receive. So this is going to now be able to be received by Unreal, and we can start doing things with these boxes. Because what Unreal is really cool about, what Mac's really cool about, is that it has things like, this is a Ableton bot Maximus P, right? So there's these Ableton sliders, right? So we can start using Ableton sliders to control things in Unreal. We can have regular sliders like this, right? Or we can have toggles and buttons and other kind of objects, and we can start using these as a more intuitive interface for doing for controlling graphics inside of the game engine. Okay. So in Unreal now, if I go to my preferences, I just need to make sure it's turned on. So I actually need to go into plugins. Sometimes it is, sometimes it isn't. I already compiled this for you, so I think it will be. At the very bottom, in my project, because it's at the project level, right? It's next to all my project files. I have OSC, and it's already enabled. If it wasn't enabled, check that box, which is a Boolean box, and then it would ask you to restart, and then you would have the jam there. So it's now a part of our project, and we can start connecting the two. I'm going to go to my project settings, and at the very bottom it has information about my plugins, and I just know that I'm looking for data from port 8000. That's the default. I can obviously overwrite that. That's a text box, right? And I can overwrite it. And it doesn't matter what, as long as the two match, right? I can make it 7474. I can make it 888. I'm gonna keep it 8000. Unreal's just the default of 8000. So let's get this working and try it out. I'm going to go talk about asset management, right? We have our assets folder. That's where we keep all the things we make. If we buy marketplace content, it'll go to other root folders underneath our content. Right? These are two ways of navigating the same folder layouts. And I'm going to go into my blueprints, and I'm going to make a new blueprint for an actor, right? Just a general one, generic one, and call it BPOSC. Blueprint for Open Sound Control. And because my plugin works, I can now add a component for receiving that data. This is going to be very similar to how we did collisions. Instead of receiving a collision and overlap, we're receiving data from another piece of software. So instead of a box, we're going to put an OSC receiver. And in the same way, we spent more time in the level blueprint, but in the class blueprints, you can right-click, and this is where you would add your overlap events. Or down here, you'd add your overlap events. And we just want to receive, when we get data, trigger. Okay, just triggered when we get data. And now it's added an OSC receiver here. Just like we have an overlap, just like we have event begin play in our tick, we have a receiver. Okay? And as I said before, this is an internet protocol, and meaning that it filters things on ports and also URLs. So we are going to, the idea of prepending and appending things is we want to either put things to something at the beginning, put something at the end. I want to put this data on a channel, and it's any channel I want to. The channel is going to be called well, we can make the channel Bob, or maybe that might make it confusing. We'll make the channel Bill. So before I send data, can you please prepend a URL, which is Bill? And you see that it is prepend. See, sometimes it's the easy things that are hard. It's going to put the word Bill in the front. To prove this to you guys, I have a little console here on the side that I pulled out from here that gives me things like, oh, I misspelled those 2 words. It's reminding me of my flaws. Thank you, console. And I can print to it just like I can print to the screen in Unreal. Printing. So now you see that this is oh, because it doesn't understand on this side. I'll disconnect this for a second. So now you see this is like an internet address. It's Bill, and numbers are floating around on the internet address of Bill. I'm going to undo this real quick. And we'll keep this connected so I can give this to you guys, and it's still working. And make a new one. So we're in the new territory over on this canvas, and we have. So we're using integers. I'm going to use a floating point because I want better data. I want to have that continuous data. So if I click here, I can do a floating number point. Otherwise, I can hit F. All right. So now, if I hold over here, I have decimal points. See that? And if I drag the certain point in the decimals, I can be at the tenths or the thousandths as I drag it down. Let's bring back over our bill and our print. And now let's send it to Unreal. So we're going to say new UDP send. We're sending it on our local host, right? We're sending it on our own computer. Otherwise, I could send it to your computer and your computer, and we can target that by finding out your IP address that is assigned by the router. And what port do we choose? 8000. All right. So even if it's a new concept, this does logically follow, right? It makes sense logically that we have different kinds of data types, and we're sending it on from one application to another by doing a local host. So in Unreal, I have here my execution pin. That's my I'm receiving ticks from OSC. We have an address here. An address is literally a different kind of data type. It's purple. It's just text that is a URL, so it's an address. And what are we sending it on? We're sending on Bill. This is our address. So I'm going to say I could be sending it to 1,000 addresses. I just want it to equal. I hit equals twice. The address of Bill. I can have 100 blueprints in there, and I only want this one to work when it is Bill. And the red data type I'm hovering over, it's a Boolean. If it's Bill, then do something. If it's not Bill, then just ignore it, right? And an if statement inside of Unreal is a branch. Right now the condition, the Boolean, is checked off, right? But we're going to use the address to be our conditional. If we're on the channel of Bill, do something. So we now have the next one, which is data. We're going to get data. Let's receive data, and let's parse this data and make it do something. The data is, by being context sensitive, we know we can only do a few things with it. And what you do here is you either push data or pop data. And this is kind of a weird phrase, but basically when I'm popping data, it's like I'm taking off a stack of hats. And there's going to be like a stack of data I can send, and I want to pop off the first data type. And that data type is a float, so I'm going to pop float. And then if I was taking it from Unreal to go back to Max, I would push it together and send it as one stream, and that's what OSC is. It's a packaging of UDP. Right, so I'm going to pop a float, or pop a wheelie. Cool. For now, let's just print string and make sure this is working, okay? So from here, I'm going to print. If I connect the float to the string, it'll auto-convert it for me. And the one thing that I always forget to do is you actually have to put it in the world. So put it in the world so it actually is being activated when I hit play. And I'm going to do one other trick, which is Unreal, because it knows it's a beast of a program to run. Whenever it's in the background and you're like checking your email on the front, it starts rendering really slowly because it doesn't want to like spin up your graphics card. Let's tell it not to do that because we're going to put max in front now. All right, so we want it to be running at full speed, and it's a setting on the editor preferences. This is different from project settings. Edit has editor preferences and project settings. I'm changing the way my editor renders. If I'd made this a packaged project, if it was executable, this would be an issue, but it's about how the way the software runs. If you're doing this in Mac, this is in the About section under the Apple. Right? So editor preferences, I have performance, and just when it says use less CPU in background, that is unchecked. All right? So hitting play, coming back to Max. I now have numbers on my left side. I have two computer programs that are connected to each other and they do things with each other. Cool. So what can we make that do? I'm going to keep OSC. It's a good template for me to have. I'm just going to duplicate it by hitting Control W or Command W on a Mac. And instead of BP OSC, I'm going to have BP, I'm going to call it BP Audio Light. And open it up. Same one as before. We just need to do a couple things. Bill, I'm going to make a new address over in, well actually let's go back to Max really quick. So Max is, in interactive installation world, Max is always used for audio processing. It's the beast for doing live, like changing people's voices and all that kind of stuff. It's awesome. So whenever I want to change my voice, which is an analog signal, to a digital signal, I need to do an analog to digital conversion, which is if I hit new for new object, I'm doing an analog to digital conversion. But there's an easy DAC, which is just has a better interface. It's a microphone, right? And if I do that, take my print and move it over to here. Now, actually, it's just getting a signal. Just a real quick thing. These are data flow. These gray lines. These are the Max part of Max MSP is data flow. When we start getting into these little checkered lines, that's the audio process. It's not actually a number. I need to convert it to a number. And this is just one of those reasons. We're not going to get too much into Max, but this is one of those things that isn't what you normally would call it. It's just called, we're going to be sampling every 33 milliseconds, and it's a thing called peak amp. What is I'm looking at for the peak amplitude that's coming through my microphone every 33 seconds. Peak amp, peak amplitude. And now I'm getting continuous data. And if I want to, I can make that look like I'll use a multi-slider. This is like the slider. Let's go over to my information. But instead of being that, I want it to be from 0 to 1. And this is like my details panel. And instead of being a thin line, I want it to be a line scroll. Let's reconnect it, and now we might be able to see this as a cool little audio meter so we can see what we're doing. I have audio. I am being audio reactive. It's kind of seems to be scaled kind of good, or well, as some people might would say. But I might want to scale it. I might want to actually make small numbers be big numbers or big numbers be small numbers. And what's cool about Max is I don't have to recompile. I can be doing this live. So when I do like a VJ set with Unreal and Max, I will do all the Unreal stuff and have it rendering the entire time, and then I'll live code Max for fun and just create all these values and scales and stuff like that on the fly. Basically, we need to scale a 0 to 1 to a different number. So we're going to say from 0, using the decimal point just to make sure that it's still a floating point, from 0 to 1 to like 0 to 2, right? So now if I put this in between, drag these little dots, I now have, it looks a little bit louder, right? I can also make this 3. It looks even louder, right? The peaks are getting higher. These little inlets in the top are actually driving these 4 values in here. So what's cool about this is I could be adjusting and fine-tuning this while Unreal is still running. So I'm just going to add in a floating point here. And now I can make it really quiet. And if I want to bring it up later on for the big crescendo, I'm just scaling it so it gets louder and louder and louder. You know, but then it starts to clip, right? I don't want to clip. I don't want to go off the edge. And then also, it's just a little bit too audio reactive. I might want to smooth it out. So we'll use 2 more things here before we go back to Unreal. One was that word clip, which sometimes you don't want to, especially when you work with audio, you don't want everything to feed back. You don't want to hurt anyone's ears. So I'm going to just put in a new object for clip, which don't go above 1. I'm going to put that beforehand just to make sure that I'm saving myself. I might want to go above 1 later on when I want to convert it to something like a luminosity value. And the other thing I want to do is take this data, and the smoothing function is called slide. It's telling me these arguments. I want it to either slide up, onset, or slide down. I don't want to have any latency when doing the hit. I want it to always be audio reactive. I want it to always be able to notice it. But then on the way back down, I want it to be a little more gradual so that I can watch those values kind of play out. So now, as I do things, it's a little smoother, right? Looks nicer, there's less jaggeds. You can really feel like I'm doing something every single time. And I can bring it back up to 2. Or maybe 3. And then 2 is fine. I'm doing all that, right? Looks good. So locked and loaded, we're going to keep it going. Let's go to here and make this drive a light. All right. We're going to come out of the slide. This is just a visual representation for us. We don't need to go through there. I might want to delete it later on or something like that. So let's do a new send and receive. I remove this puppy over here. I'm going to say send to UDP. And I'm going to receive to UDP. And now I can delete this line. So our one that's printing to the screen in Unreal, it's still doing so. But also this one could do so. I can start making, I don't want to have all these wires going everywhere. I'm using these send and receives to simplify it. But I want to send this one over the new channel of light. New channel, same IP import. If I hold down Alt, I can duplicate things in this software. So Alt. So now I'm getting light as well, sending to Unreal. So let's come back over here. Our channel is no longer Bill, it's light. Yeah. So we're editing that. And what do we not have? We don't have a light. So let's disconnect the stuff that's in the other patch. We want to add in a point light. A pretty point light. And we'll bring in a reference to the light. And we're just going to be driving the intensity of the light, right? This is just, the setting is right here, the intensity. And by default, it's 5,000. All right, brought in a reference. So dragging up there, context sensitive, set intensity. If it's true, do it, and do it off of this floating point value. Don't forget to drag it into the world. and then hit play. Let's go hang out over here. Shift F1 gets my mouse back. Let's come over to max. And I'm not seeing anything just yet, but we also have established that lighting intensity was 5,000 from before. So I'm going to select on here, lock it, select on here and say, give me 5,000. Now we're seeing an audio reactive light. Where'd you go? You can't see it because lights are invisible, but you get the idea that I'm now having a world that could be audio reactive. And in the same way we did all these other boxes, I could take this light. Where are you? Audio light. There we go. And then there could be tons, right? And they're all objects of a class. And a rave is going on. So we hit play now, and now the whole side of the room is doing whatever. I think we did something to the floor so it doesn't receive light, but whatever. You can see, or if we here again, if we don't want to stop it, we can always. Right. So now I'm changing my scaling values, and I have an audio reactive scene. Cool. So that's cool. Boom, boom, boom. And we can make it slide off a little bit faster or slower, whatever we care about. Okay. So our objects can be doing this stuff as well, and we can put our objects into the lights. First of all, any questions? It's cool stuff though, right? It's really quick. There's no latency. It's super fun. So I wonder if I wonder if I still have my. I found a really cool pumpkin I wanted to hook up. This is my regular downloads. Where's my class download? I had pumpkin with, that was somebody else's. Okay, I'm just going to go to the free 3D models and find something real quick. We'll go through the process of static mesh because we spent more time on skeletal mesh. Let's do a second on static mesh. So the free 3D models.com, and let's find ourselves a little pumpkin. I spelled pumpkin. Pumpkin. All right, let's find somebody who has like this. That works. Like that. What do we say? That one looks good? Let's do it. Let's download. And oh, we have good jack and bad jack. That's interesting. I'm going to come over to the project that I have synced, and I made a little folder full of imports where I'm putting your guys' content, except for not my own. So here's Todd's. And should we want to do something in Cinema 4D? It's also a Cinema 4D file. And I'm going to go to class folder, find Todd, find my static meshes. And we'll bring in my pumpkins. And let's import it. Imports. Good jack, bad jack. I'm glad I got both. That's nice. I'm just going to keep it default on static meshes. Now, it's unknown what the polygon count is. I do want to be respectful of polygon count. That's something that's important about running things real time. So once we're yellow is warnings, so it's not that important. This just means that it's a Cinema 4D error. Okay. It has the inside and it has the outside. That's what I was hoping. It has a different texture on the inside. Cool. But I don't really care about having separate meshes. I want them to be kind of merged, so I'm dealing with less effort. Actually, no, it's a good lesson too. All right, everything's fine. We take a look at it, and we can see that. And this is the static mesh editor. Here we go. It is Thank God, it's 36,000 triangles. That's way too much. I only like characters to be 40,000, something like this. I'd want to target something like 2,000. Right? We don't really need to have this dense of a mesh for something this simple. If I show it as a wireframe, that's like way too much, right? It has an inside and an outside. It's just a little too much for me. So we're going to do something that's a really great feature of Unreal. Is they took this company, this won many Academy Awards, called Simplygon. I don't even know if they're still around. Simplygon, which is a level of detail generator. It's a way of, we were talking about maybe on the first couple of weeks, where when you're doing a video game, sometimes if a cast is really far away, you want it to be just a PNG, but when it's really close up, you want to have all the different details. And video game engines automate that, and they'll make like 5 levels of detail, so that as you get closer, it swaps it out. And Simplygon is one of the best in the world at doing this, and they're not integrated into Unreal. Unreal's free. Simplygon's really expensive. It's something that like you have to pay thousands of dollars to Houdini for. So I actually sometimes people working in different platforms will just use Unreal just to use the Simplygon integration. And if I go over to the static mesh assets, I can go to my reduction settings, and I can say I either want to change how many. The percentage, I want to go down to a percentage of how many, or I want to go and do a specific count. I can only budget this many draw calls, and I want it to be 100. I'm going to take a percentage, and we're going to go from 36,000 to 3,600. Okay, we'll go to 10%. And let's go back here first and say apply. Maybe a little aggressive, but it's still, still cool. So what's important about this that's different from decimation that's in all software packages? This maintains UVs. So everything stays exactly in place. It would shred all that in Maya and Cinema 4D if you just did a polygon reduction. That's what's so intuitive about this. It understands features, and then it preserves those features. And it's still referencing my original object. Should I say, oh shit, I went too far, let's go up to 25% and apply changes. It's non-destructive, and I can come back up to that looks great to me. Maybe there's a little bit of stuff we can work around with, hard edge angles, right? We can definitely play around with this and finesse it a little bit. But what's great is that we have this built into the game engine. So I have this for right now. That's good enough to show you that. And then here where you can start making new LODs and start making like 5 of them if you wanted to keep them all around. I just want this one. All right. So inside of my jack, I'm going to make a blueprint. And this will be the last thing we do today. And it's going to be called BP Good Jack. And we're going to load in both of those static meshes. I'm just going to drag and drop them in. Good Jack and Good Jack. And I think they'll probably have the pivots correctly, so that if I bring them both in, they'll just be right. Yeah, they're lined up fine. I do notice that they're backwards, though. These scene roots are good for just rotating things around and offsetting them. We want all our blueprints to be kind of centered. If it was like way off, I can take it back into Maya and put the pivot point in the correct place. But I can also offset it here using these little nulls. So I use a little scene root, put the static meshes onto the scene root, and if I rotate it around 90 degrees or 180 degrees, Jack's facing the right way. And you can start seeing how things get complicated or at least more advanced when you start doing a lot of that kind of stuff. Cool, so we'll be using Jack for a little while in this class, and I'll figure out how to get the edge settings look a little better. Then what we want to do is we want to drive the internal fire of Jack so he's like throbbing with the music, right? So let's take a look at this inside of it, and we have inside texture. Open it up, and it's now been 2 weeks, so I'm going to kind of go over this again. We wanted to convert the color or the emissive channel to a scalar parameter. It's going to be a parameter that has a single scale, right? It's a one number, and then we're going to make an instance of it so we can allocate space to it. if I bring in, if I type in S and click, and call this bright, all lowercase, I'm going to multiply it by the color. I'll make the color brighter. For multiply or for the scalar? Scalar is S. M is multiply. A is add. They're all listed kind of here. They're really small, but you can see they're on the side. The ones that are really useful. And if I put this at a 1 by default, then I'm ready to go. So you see how it took a while though? I'm just driving one number and it takes a little while because I'm not allocating resources. The game engine can do it in real time. We've seen it before. So to do that, we're going to tell the engine to allocate more resources for it. And we did that by creating an instance of it, if you remember this. So clicking on that material, if I right click it, I have an instance of it. With it selected, I'm going to go back to my blueprint and apply it. It's going to use selected asset from the content browser. Nothing changed because it's the same thing, it's just an instance of it. But now what's cool about this is that if I put this blueprint in the world, it's huge. I might scale down too. I can come over to the brightness, and now we can take a look at it in real time, right? It's allocated resources to it. It's always great to have things modeled. I mean, if on purpose you don't want to, that's fine, but it's always good to bring in things at the correct scale. When you import assets, it does things like apply weight and mass to them. So usually I'd maybe like pitch this back to my asset person, my technical artist, and say, can you scale it accurately or give it a specific scale? But because we have the scene null here, I can also probably scale it here. You're too tiny. Scene null and bring it down to like 0.2. And so now it's made both the top of the jack and jack itself are both scaled correctly. Cool. Zoom in. So let's start the programming component of this. And right now I've only used floats, I just realized, but like what's a boolean that we've been using in class constantly that we can do? We've also been toggling visibility, right? So maybe I want Jack to only show up occasionally, so maybe if I don't get to it right now, we could toggle visibility on Jack and then also make him glow. So let's get into the blueprint and let's bring in that OSC component, OSC receiver component, and right clicking on it, I can add an event for receiving it. Then I want to do two things. Well, we're gonna make a channel for good Jack over in Max. So bring up Max. We'll deal with organization later on. All right. So here is my toggle. This is going to send me zeros and ones. If I print it out, you can see it's probably on off 0 1 0 1. This is now an integer, right? Or it could be a boolean. I'm going to make a new channel for prepending good Jack. Got prepend again. That's just prepend good Jack. And so I'm now sending good Jack 1010. Let's send to, we're going to do send to UDP, and then UDP is already looking for sends. So now I could toggle Jack off and on. I will then look for the channel. I'm going to hit equals equals. for the name. We called him Good Jack. And then we're going to do our if statement, which is a branch. And then because I put both of these assets on a null, I grouped them, I can address them by just by addressing the scene null. And I can say set visibility. And you'll see that it includes propagate to children. So I'm going to toggle on that invisible scene null, but it's actually going to turn off and on both assets underneath it. This is a little asset management kind of trick. Otherwise, I could have imported them and said merge assets when I merged, and I could still address the different materials. They still have the different UV channels. And what's cool about this one is I really don't need to pop a bool. I could, but let's just try it without it. Let's try it with it. Let's just see. Pop bool. It's actually going to be an int, but we'll see. Connect it. And we're going to make sure that it's visible by default. Let's try it. So Jack is no longer that Jack. Jack is now... Wait, is that BP Jack? Yeah, we're good. That is Jack. All right, thank you, Jack. And let's go over to Max, and let's see what happens. Off, on. Cool. So that's kind of a bool and together. When I said the homework to do a bool and do an int, you could probably combine them, unless we're not going to get into arrays until maybe later on. So that could be fine for the homework. Cool. So I mean, I guess to be super gratifying, we'd want to have the audio reactive Jack lighting on the inside, and then we can call it a day. So this isn't a straightforward process. We've done it once before, but I'm going to go ahead and go through it with you one more time. We have here, we have resources like memory and CPU and GPU allocated towards the instance, right? We could drive it in real time, but we need to make it dynamic. It needs to be able to be driven real time at runtime. We can preview it like this way, but we need to be able to do it dynamically. To prove a point, if I hit play, and let me come over here. Where are you? And run it. It doesn't update until I let go of the mouse. It's not dynamic. Right? So we need to make it dynamic. Stop. And we want that to happen on event begin play. Go ahead and make sure that we're going to create a dynamic material instance. It's going to be the bottom. Nope. The internal material is here at the connect, and then you want to create a dynamic material instance. No, there's two of these, and that's one thing that I wish they would fix. Dynamic. Yes. Oh, I'm an idiot. Yeah, everything's fine. Yeah, this is great. And what is the material? It's that one. Those right here. It's that inside inst. If I select it here, make sure it's there, and if I come back over here, I can then bring it in. Right now, now we hit play. It's ready to go. It's dynamic, and all we have to do is set the parameter for it. So I'm going to make a stack of these. So I'm going to pop off a float, and then I'm going to take. I actually don't want this. I want this. I want to talk about this material, and this material only exists when I hit play. So I'm going to promote it to a variable. And we did this last time. It was called inside material instance dynamic, or dynamic material instance, either one. Grab a reference to that and set the scalar parameter, which we called bright. We know that from over here. Bright, also that's the name right there. It's case sensitive. And then here's the logic waterfall, as they call it. If it's not true on, we're gonna do different channels. Yeah, we'll do different channels. So if it's not true for good jack, it might be true for the next one we have, which will be from here. We're going to send it to a different channel. This one can go there, and then this one can be new pre-pinned jack audio, and then that one will send to UDP. Equals. There's a way to do this way more simply, but this is like the way to start, pretty much. Jack audio. So if it's not good jack, check to make sure it's also not jack audio. But if it is jack audio, be here. And this is called a cascading like if statement kind of thing. Let's see if it works. Who knows? Might not. Are you working? Let's debug. Are you working? So it's definitely getting values. If I hold over, I see it's still 0. Let's see what we're doing wrong. We're prepending jack audio. Let's make sure we still do the other thing. Alright, we can toggle it off and on. That's cool. Maybe it's just because actually the scale value is probably crazy because of the lights. Doing it runtime. Type in 0. 0, 0, 0. Looks like it's super dark. Fun. I just don't think it's getting the data. I'm gonna not do it this pop way. I'm just gonna, instead of doing this, I can hold down Control and I can just drag it straight from up there. Just get it from I have them on separate channels. That's the way to set it up. So now you're gonna be audio reactive, aren't you? You are an audio reactive pumpkin. Yes, you are. Yes, you are. There we go. Start with a little run around there at the end. So anyway, this is obviously this is used for gaming and stuff like that, but this is kind of fun when you want to get into try and manipulate in other ways. So this can also be a slider. This right here would just send 1 0 1 0 1 0 1 0 if you just want to make it rapid fire or be on like a snare and turn itself off, right? So this is called a momentary. This is a toggle. Momentary, slider. These are the same things. Right? This goes from 0 to 127. You might have to use that scale object to scale 0 from 127 to 0 to 5 million. Everything's kind of on this canvas that you need to do. Just basically taking 3 interactions. You can even redo your interactions you did 2 weeks ago if that's all you want to do. Just kind of as much as you want to have fun with this. But yeah, any questions about this stuff? Audio Reactive. So it's about what song you choose in your screen recording that we're all going to judge you on, right? I always go for an old favorite from 2001. Anyone know Tortoise? It's a Chicago band. You're not going to work on me? If I used the same URL, that's when I would have been popping it off. But because I used two different URLs, I could pull them both from the data source. And that was the thing that I got confused at the end. So I wasn't packing them together.
Could do that much better.
For right now, let's keep it separated, but you would have to use one other object, which is called packing, because you're creating a list, and you just need to tell it what order the list is coming into. And we're not going to drop this. We're going to continue this all next week. So we'll get into more complicated things. Eventually, you're not going to do those branches. You're going to do a thing called a switch, where you just make a whole list of URLs, and they're all just going to come off there. Right? I'll show you the one I made for the Gambino project. It's like this big, you know.